Hey class, this will be an overview of ThinkCentral homework lesson 110, practicing adding and subtracting unlike mixed numbers. Problem number 1, we're comparing finding the difference between two unlike fractions. So the denominators are not like, so we need to find like fractions. Something to be aware of is anytime you want to find a common denominator, you can always multiply both denominators together, and that will give you an automatic like fraction. So in this case, multiplying 3 by 11 gives you 33, and then remember the double rainbow. What you do to the bottom, you do to the top. You end up with 21/33 minus 11/33. So that would give you a difference of 10/33. So that is one strategy you can use to compare unlike fractions, multiplying the denominators together to get you a common denominator. Problem number 3, I'm skipping, I'm just doing the odds because they're all the same. They're just practice. Just make sure you identify that you are adding here. So make sure you look at the sign, unlike fractions. In this case, look to see if one of the denominators is a factor of the other denominator, or the other denominator is a multiple of the other denominator. So 20 is a multiple of 4, so we're going to use 20ths. You're going to go, here's my factors here, 4, 8, 12, 16, 20. 4 times 5 is 20, 3 times 5 is 15. You don't have to change this one, this remains the same, so it's 1/20th plus 15/20ths, and that is 16/20ths. Go ahead and simplify this fraction. They're both even. You can divide them by 2. Also, they each have a common factor of 4. So you can divide each of these by 4, and that will give you a simplified fraction. So simplified, the answer is going to be 4/5. If you did divide it by 2, you'd end up with 8/10, and then you divide that by 2 again, ending up with 4/5. So it's always best to divide by the largest common factor of the two numbers to get a simplified fraction. Same problem here. We are adding two unlike fractions. Notice that I did the multiples of 30, 30, 60, 90, and the multiples of 45, 45, 90. Go ahead, if you don't know these facts in your head, practice your math facts, but then also use a calculator to help you find these common multiples. So the common denominator is going to be 90. So you're going to add up, you're going to do a times 3 times 3 here to get 21/90ths, and you're going to do a times 2 times 2 here to get 32/90ths, and then you're going to add up 21 plus 32 over 90 to get your sum, and that's going to equal 53/90ths. Go ahead and check to see if you can simplify that, but there are no common factors between 53 and 90. Actually, 53 is a prime number. There's nothing, just 1 times 53 equals that, so that's the simplest form, 53/90ths. What they're asking us in this question is, what do they have in common? And it's kind of hard to see this. This one's a subtraction, this is an addition, and this is a mixed number subtraction. So that's not in common. But if you notice this, what they're saying is comparing these denominators, 13 and 26, 4 and 24, and 3 and 18. What they're trying to get us to think about is one of the denominators is a multiple of the other denominators, or one of the denominators is a factor of the other. So we're going to use the greater number as the common denominator because it's a multiple of that number. In other words, you're going to use 26 as a common denominator for this problem, 24 for this one, and 18 for this one. Problem number 7 is just comparing mixed numbers. You see that they're unlike. So 3/4 doesn't change, that just remains fourth, and you change the half into fourths by double rainbow strategy, giving you 2/4, subtracting 3/4, and 2/4 gives you 1/4, and 3 minus 1 is 2. So it's a fairly straightforward problem. Again, I suggest that you write them vertically, separating the wholes and the parts when you do these problems. So problem number 9, the only thing tricky about this, when you do write them vertically and the holes and the parts, you notice there are no parts over here. So you're going to want to, I always just do this to give you a place value holder. Then you have 4 sevenths. You cannot take away 4 sevenths because you don't have any sevenths here. So you regroup or rename this as 3 and 7 sevenths, because 7 sevenths is a whole. You're taking that one whole over here that you renamed and you're renaming it as 7 sevenths. Then the problem is really easy. 7 sevenths minus 4 sevenths, 3 sevenths, 3 minus 1, 2. Problem number 11, you are finding the sum of two mixed numbers. They are unlike fractions, but I do know that 12 is a multiple of 4, so I'm just going to multiply times 3 times 3 to get 9 twelfths here. I add those up, 7 twelfths, 9 twelfths, gives me 16 twelfths. That is an improper fraction, so I'm going to simplify that by how many times is 12 going to 16? It's 1 time, and there's 4 parts left over, so 1 and 4 twelfths. You take that one whole and you regroup it into your wholes, and you end up with 6 wholes and 4 twelfths. Now 4 twelfths can be simplified because they both, 4 and 12, have a common factor of 4. So you divide them both by 4 and you end up with 1/3. So your answer should be 6 and 1/3 in simplest terms. And final problem we're looking at is a word problem, so we unpack it. Every week, Mr. Park asks for 1 pound of potato salad at the deli. The line plot shows the actual weight of the potato salad the deli worker gave him over the week. So this is a line plot. Each one of these dots represents one trip to the deli. So these are all his trips. One time he got 15/16, and 2 times he got 1 pound, 4 times he got 1/16 pound, etc. So you find the difference between the greatest, 1 and 5/16, and the least, 15/16. So when I rewrite the problem, I have 1 and 5/16 minus 15/16. I don't have enough 16ths here to take away 15, so I rename this fraction, leave me 0 wholes. I add 15/15 to this, 15/16 to that, leaving me 20/16, and then I can subtract 15/16, and that leaves me with 5/16. So 5/16 is the difference in pounds of the potato salad that he got between the greatest and least. And that's the end of the lesson for homework. Make sure you are asking for help. Mistakes are cool, so not knowing how to do it is just an invitation for you to develop mastery. Bring your questions to class, send me an email, and let me know, and I will help you. Thanks. Bye.